Alright, I'm going to show you a little bit about harmonics right now. This may or may not be difficult to see on the tape. You'll notice that there's a spot with a lot of motion here. There's another one in the middle. And there's one down here at the end. I'm using the black background to show it. So that's one antinode, two antinodes, three antinodes right here. So this is known as the third harmonic. Okay? I'm going to keep the frequency down at the other end. I'm going to keep it constant. Notice that this is under tension. I think that's like 300 grams. So now I'm going to go ahead and put these other 200 grams on here. And I've worked this out beforehand. So I'm trying to get this to where you can see. I'm going to add 200 more grams. And this will pull down because it's more weight, which is more force. Try to do this with one hand. Got it? And let's look at what's happened up here. Now we get one spot moving here and one spot moving down here. We have just switched from the third harmonic to the second harmonic. And mathematically why that is, I'll show you in a bit.
Alright, so what happened when we were doing the changing the harmonic there? Well, let's discuss. Well, here was our first harmonic, and we were at harmonic F, or we were at a frequency of F. Well, we were still at a frequency of F here. Let's call this entire length of the string L, on both, of course, because we didn't change that. Well, what's our wavelength? Well, here our wavelength is 2/3 L, because this is one wavelength from here to here. That's one wavelength. But down here, the whole thing is one wavelength, and we'll call that maybe, prime. So the wavelength prime just equals L. Well, since V equals F times lambda, our first V, our first velocity of the speed, is F times 2/3 L. Or, if we wanted to put that, 2/3 FL. Well, down here, our new speed, make that look a little nicer, our new speed equals F times our new wavelength, which is just L. So notice that our new wave speed is 1/3 faster than our initial, or I guess I should say this one is 2/3 of the second one. So just as we suspected, we tightened up the string and we got a faster speed. Now if you think about this, our wavelength, because it's actually moving back and forth, there's only one string, here's one wavelength, and here's one wavelength. So in one up and down motion, 1 hertz, this one goes farther in the same amount of time and is faster.